Hello class, today we're doing chapter 6, Algebra, Equations, and Inequalities. We will be looking at 6.3, Applications of Linear Equations. Our objectives today are to use linear equations to solve problems and to solve a formula for a variable. We will have a strategy for solving word problems. Step 1, we will read the problem carefully several times until you can state in your own words what is given and what the problem is looking for. Let x or any variable represent one of the quantities in the problem. Step 2, if necessary, we will write expressions for any other unknown quantities in the problem in terms of x. Step 3, an equation in x that models the verbal condition of the problem. So we're going to write that equation in x that models the verbal conditions of the problem. Step 4, we're going to solve the equation and answer the problem's question. And step 5, we're going to check the solution in the original wording of the problem, not in the equation obtained from the words. Got to make sure it makes sense in terms of the words, because if it doesn't, maybe we didn't do something right with the equation. Algebraic translations of English phrases. Typically for addition, we'll use words like sum, more than, increased by. For subtraction, we'll use minus, decreased by, subtracted from, difference between, less than, fewer than. Now, these aren't the only phrases that we could possibly use. These are just some common ones. Multiplications, sometimes we'll use times, product of, percent of a number, multiplied by, twice. Division, we'll use divided by, quotient, perhaps even reciprocal. Example 1, education pays off. The graph shows median yearly earnings in the United States by highest educational attainment. It certainly looks like you can make more money with more education. However, workers who make more money pay a higher percentage of income in taxes, so it's wise to consider after-tax earnings when deciding if that higher degree will pay off. So, chart here, median earnings of full-time workers in the United States by highest educational attainment. The red is before tax income. The orange is after tax income. First category is some high school. Next category is high school grad. Following, some college, associate's degree, bachelor's degree, and then master's degree. The median yearly after-tax income of a full-time worker with a bachelor's degree exceeds that of a full-time worker with an associate's degree by $11,000. The median yearly after-tax income of a full-time worker with a master's degree exceeds that of a full-time worker with an associate's degree by $21,000. Combined, three full-time workers Combined, three full-time workers with each of these degrees earns $149,000 after taxes. Find the median yearly after-tax income of full-time workers with each of these levels of education. Step 1. Let x represent one of the unknown quantities. We know something about the after-tax incomes of full-time workers with bachelor's degrees and master's degrees. They exceed the after-tax income of a full-time worker with an associate's degree by $11,000 and $21,000 respectively. We will let x equal the median yearly after-tax income of a full-time worker with an associate's degree. Step 2. Represent other unknown quantities in terms of the x. X plus 11 will be the median yearly after-tax income of a full-time worker with a bachelor's degree. So, all right, let's take a second here, see what we're looking at, because I'm sure by this point, if you're just following along and you haven't paused to reread this a few times, you might be a little lost. Remember, step 1 is to pause and reread as many times until you understand what we're doing. This says that x is the median yearly after-tax income of a full-time worker with an associate's degree. Now this x plus 11 is the median yearly after-tax income of a full-time worker with a bachelor's degree. Okay, let me show you how that makes sense. I'm going to go back a little bit. Okay, so the x we said was the after-tax income of an associate's degree. The associate's degree, if we're looking at it here, is right here after tax in the orange column, right? And then we said of the bachelor's degree we have determined is 11 higher than the associate's degree. So if this is X, then this is technically X plus 11. Then we're going to go to master's degree as well. So if you follow along, the master's degree will be 21 more than the associate's degree. So if I'm going to click back here. Technically, the difference between here and here is 21. So this is technically X plus 21, because X is your amount you make as an associate degree. X plus 21 would be the amount you make as a master's degree, because we're putting everything in terms of X. Hope that kind of visually helps what we're kind of accomplishing here. Step 3, we want to write an equation in X that models these conditions. We're looking at basically an associate's degree plus a bachelor's degree plus a master's degree. That equals 149,000. So this was associates. I can't spell. So associates, we'll just abbreviate. This is bachelor's and this is master's. Okay. So now that we have this equation here, X plus 11 plus X plus 21 equals 149. Technically, we can now solve this equation for X if we wanted to. All we need to do is simplify. We can essentially drop these parentheses because nothing's being done to them. They're not being squared. They're not being multiplied. So essentially what we're looking at is 1, 2, 3 X's. So 3X. And then 11 plus 21 is 32. So 3X plus 32. If I subtract 32 from both sides, I wind up seeing that 3X equals 117. And then if I divide by 3, I see that X equals 39. So, median after-tax income of an associate's degree is 39. Median after-tax income with a bachelor's degree is X plus 39 or X plus 11 equals 39 plus 11 equals 50. And median after-tax income with a master's degree is X plus 21 equals 39 plus 21, which is 60. Okay, we want to check the proposed solution in the wording of the problem. And when we do that, we see that the solution checks. So we got X is 39, 50, and 60. If I go all the way back here, okay, we can see right here that 39 is indeed where this line ends here. And then if we follow the other ones, it's 50 and then 60 as well. So everything's kind of checking out here. Okay, we basically found an equation to represent our situation that matches exactly with our words and with our graph. Okay, you're like, okay, I saw the graph. What was the point in modeling that with the equation? Sometimes you won't be given the graph. You'll just be given the equation. And you'll need to be able to solve it through. And it's good to have an equation that models back to the graph, because sometimes it's easier to plug numbers into the equation rather than to look at the model every time. Let's look at example 3, modeling options for a toll. While planning your Florida vacation, you find out that you'll need to cross a toll bridge. Toll bridges love to take some money. I always try to avoid the toll route personally, but that's beside the point here. One payment option requires purchasing a transponder for $20. With the transponder, you pay a reduced toll of $3.25 each time you cross the bridge. Another option is toll by plate. With this option, you pay the full toll of $4.25 each time you cross the bridge, plus a $3 administrative fee for each crossing. Find the number of times you would need to cross the bridge for the cost of the two options to be the same. Oh, tolls. I hate tolls, personally. They have toll roads in like all over the place. There's some in South Carolina, not many. There's plenty in North Carolina, and they are definitely in Florida. Florida has a really big toll road. All right, let's actually solve this problem out. Well, step 1, let X represent one of the unknown quantities. We're going to let X equal the number of times you cross the bridge. That's what X is going to represent. The number of times you go over this particular bridge that they keep tolling you for. Step 2, we want to represent another unknown quantity in terms of X. Right now, there's no other unknown quantities, so we can skip the step. So sometimes steps are skippable if there's nothing to really represent them here. Step 3, we're going to write an equation in X that models the condition. Okay, this is where we get into the meat of the problem. The cost of the transponder is the cost of the transponder, $20. They only charge you that once, plus the toll, which is $3.25, times the number of crossings, X. So essentially, what we see here is that one side of our equation is the cost of the transponder plus the time, the $3.25 times the number of times we cross the bridge. We want to see when that is equal to this other cost. Okay, so for the toll by plate cost, you must pay both the toll, $4.25, and the administration fee, $3, each time you cross the bridge. The cost for toll by plate is the sum of the toll and the administrative fee, so the $4.25 plus the $3. They always sneak a fee in there. You ever notice that? So overall, it's $7.25 times the number of crossings, X, that we go over this bridge. So if we're just going to pay toll by plate, we're going to pay $7.25 every time we cross this bridge, X number of times. Let's see if we can now solve for X and see when those are equal. So we've got our equation here. Pulled it from the word problem. Now if I went too fast, please pause, read it, line it out as best you can, see if you get and match what I get. Go back, watch it a few times. That's why we got it on the YouTube, right? You can pause, rewind, fast forward, do what you need to do. Make sure you understand how to get that equation from the actual word problem. That is the key and meat of this lecture here. So we've got 725x equals 20 plus 325x. First thing we want to do is get our x's together, right? So I'm going to subtract 325x from both sides. What we're going to get is 4x equals 20. Now, we need to get rid of that 4. We're multiplying here, so we're going to divide to get rid of it, so that the 4's will cancel out. 20 divided by 4 is 5. So we can see that if we cross the bridge 5 times, we're going to wind up paying the same amount either way. Because X represents the number of times you cross the bridge, the total cost of toll by plate is the same as the total cost with the transponder for 5 crossings. So if I'm crossing it 5 times, it doesn't matter if I'm doing toll by plate or if I'm doing it by transponder. It's going to cost the same either way. So maybe I don't buy the transponder, I just do the toll by plate. Or maybe I buy the transponder just so I'm not having to worry about doing the toll by plate every time. Maybe it's a more inconvenient process. But either way, it's going to be the same amount of money. What we can also see here that's not modeled in this problem, right, is that, if we're doing it less than 5 times, the toll by plate is going to actually be less than the toll for the transponder, right? So toll for the transponder only starts being better over 5. Anyways, step 5, check the proposed solution in the original wording of the problem. The problem states that the total cost of the toll by plate should be the same as the total cost with the transponder. Let's see if they're the same with 5 bridge crossings. So toll by plate, 425 times 5 plus 3 times 5 equals 21.25 plus 15, which is $36.25. That's what we're going to be paying for our 5 crossings using toll by plate. Now for the transponder, we paid that $20 initially for the transponder, only had to pay that once, paid $3.25 for those 5 crossings. So we're looking at $20 plus $16.25, which does total out to $36.25. So indeed, if you cross the bridge 5 times, both options are going to cost you $36.25. Thus, the proposed solution, 5 crossings, satisfies the problem's conditions. At 5 crossings, I'm paying the same amount of money either way. All right, take a deep breath. Pause if you need to. Go get you something to drink, because word problems, they can throw you for a loop. I don't want to overdo you all at once. So if you need to pause at any time, please pause. Get you some fresh paper, whatever you need to do, because I know word problems seem to be the bulk of what intimidates students that take this style class. Now, example 4, a price reduction on wireless headphones. Your favorite electronics retailer is having a terrific sale on noise-canceling wireless headphones. You'll finally be able to listen to music or Professor Shipes lecturing you in peace. After a 40% price reduction, you purchase headphones for $192. Just to listen to me, right? Crazy. What was the price of the headphones before the reduction? Okay. Step 1, we're going to let X represent one of the unknown quantities. We will let X equal the original price of the headphones prior to the reduction. Step 2, we're going to let represent other unknown quantities in terms of X. Right now, we don't have any other unknown quantities. The only unknown quantity we have is what the price was originally because they didn't tell us, so we're going to find it out. Step 3, we're going to write an equation in X that models the conditions. The headphones' original price minus the 40% reduction is the reduced price, $192. That's from the problem. So we look at it. X is the headphones' original price minus that 40% reduction. So we reduced the original price X by 40%. That's where we got the 0.4 times X. This is a 40% reduction right here. Minus 40% of X. Comes from straight right there. That equals the $192 that we wound up paying, which I still think is too expensive, but that's beside the point. Now we have an equation here. It says, step 4, we're going to solve the equation and answer the question. So I have X minus 0.4X equals 192. Now X minus 0.4X reduces to 0.6X. Okay. Now, if we're going to do this, what we need to do next, what are we doing here? Trying to see what happened. So, trying to see on my PowerPoint how we got from here to here. So, we've got 0.6x equals 192. I need to divide by 0.6. I'm not really sure what's going on here. So maybe it was just a typo or an extra 0 jumped in there. Apologize for that. So if I divide by 192 by 0.6, let's just check this answer because evidently I have a typo in my lecture. Happens, not perfect. Try to be. Never seems to work out. So 192, check it on your calculator while we're at it. Yeah, still get the correct answer, 320. So ignore this last step here. It was incorrect. It was a typo. That was supposed to be 0.6, not 0.06. My bad. All right, so I'm doing 196 divided by 0.6, and that indeed does give me X equals 320. Little typo here. No biggie. Scratch it out. Correct it in your notes. It's supposed to be 0.6x. We're going to divide by 0.6. Don't know where that extra 0 came from. We divide 192 by 0.6, and we see that the original price of the headphones, which was surely outlandish, is $320. So the headphones price before the reduction was $320. But lucky you got it after the 40% reduction, so you got it for only $192. Now let's check that in terms of the problem, because it's always good to check your work. So check the proposed solution in the original wording of the problem. The price before the reduction, $320, minus the 40% reduction should equal to the reduced price given in the original wording, $192. So if we look at 320 minus 40% of 320, well, what's 40% of 320? 40% of 320 is 128. So if we do 320 minus 128, that does give us 192. That is the reduced price that we paid. So hey, we were right. We were correct. 320 is indeed the original price. Oops. All right, example 5. Solving a formula for a variable. Let's solve the formula P equals 2L plus 2W for L. Now, let's hope that you've seen this formula before. This is the formula for perimeter. Perimeter is the distance around a rectangle, square. That is 2 times length plus 2 times width. But in this case here, we're just going to solve this formula. Doesn't give you any background, but I figured I'd give you a little bit. We're going to solve this formula for L. So we need to get L by itself. Not really worried about the P or the W. We're just going to move them around as if they were regular numbers. So in order to get L by itself, I'm going to get rid of this 2W, and that way I can have at least the L on the L over here by itself for the most part. So this looks like P minus 2W, and then these 2W's here cancel out because I just subtracted them off here. And I get P minus 2W equals 2L. Now to get L fully by itself, I need to divide by 2. I need to divide this whole thing by 2. That's usually where I see the mistake. Sometimes people will only divide one of the two by 2. You got to divide the whole thing by 2. Divided the whole right side by 2, so divide the whole left side by 2 as well. So what I'm looking at here is P minus 2W over 2 equals 2L over 2. That 2's going to cancel that other 2 out there, so that L itself equals P minus 2W over 2. This is our solution. Like I said, just treat the letters as if they were numbers for the most part. Move them over, right? Move them over, multiply by them, do what you got to do. In this case, we just simply had to add them over. Not a big deal. We have our solution. Perimeter minus 2 width divided by 2 equals the length. Example 6, solving a formula for one of its variables. The total price of an article purchased on a monthly deferred payment plan is described by the following formula. T equals D plus PM. T is the total price, D is the down payment, P is the monthly payment, and M is the number of month one pays. Let's solve this formula for P. We need to isolate the P. We have T equals D plus PM. We need to get that P by itself. First thing we need to do is subtract off the D. So let's do that. I'm going to subtract D from both sides. So T minus D equals D minus D plus PM. These cancel each other out. Boom. I'm left with T minus D equals PM. Still need to isolate the P. Gonna need to divide by M in order to do that. So if I divide by M here, I need to do it on the other side. Alright, that M's going to cancel that M. And then I'm going to be left with T minus D over M equals P. And I have solved and isolated for that P. And I have my answer. So T minus D over M equals P. P, once again, is the monthly payment. So P will be what we're paying monthly in this proposed formula. Okay. T is the total price. Right? That's what the equation was originally solved for. We know the total price now. Maybe we don't know what we're going to pay monthly. Typically, they tell you that when you go to the dealership, right? They're like, okay, this car costs $62,000. And then you work with them to determine how much you're going to pay monthly and for how many months to pay it off. So sometimes it's worth having that equation for the monthly cost rather than the overall cost. So we back solve for it. No big deal. This concludes chapter 6.3. Please go on and try your homework. It's located on my math lab. If you have any questions, don't hesitate to reach out by email. And I will see y'all next time.